Hi guys. Okay, we're going to talk today about graphing square root and cube root equations. Okay, so we're going to look at equations that look like this. F of x equals the square root of x minus a plus b, and f of x equals the cube root of x minus a plus b. All right, these functions will look like translations of these two graphs right here. So this is the square root of a. Okay, this is the cube root of, it's the square root of x. This is the cube root of x. Okay, so these are going to kind of look like an arc, the square roots, and this is going to look kind of like a big old stretched out S. Okay, now what are the domains and ranges of these? Well, let's look at the square root. The domain is going to be the set of all x's. Now, where do square roots, what numbers can you put into square roots? Well, I can put in 0, and I can put in positive numbers. I can't square negative numbers, so x will be greater than or equal to 0. Okay, and then over here, if you look at this, I can also do negatives over here, so the domain of this is going to be all real numbers. Okay, now let's look at the range. What numbers come out of this? It's going to be the set of all y's. Now I don't get negative numbers out of this equation, I only get positives, so it's going to be y is going to be greater than or equal to 0, because I can get 0 out too. Square root of 0 is 0. Okay, but everything else is going to be positive. Over here, I'm going to get, now this doesn't, let me comment more on this. This looks like it levels off. This never levels off. This gets as big as you want. Okay, so if I want to get 1,000,000 out of this thing, I just have to have a really big number to square root. If I want to get 1,000,000,000, I need a really big number. Okay. Here with this also, it takes longer even than this does, but this is going to get as small as I want, this is going to get as big as I want. So the range is going to be the set of all y's. Okay, I'm going to get any number that I want out of there. Okay. Graph the equations. F of x is the square root of x minus 3, and g of x is the negative square root of x minus 3. Okay, so if we looked at these other graphs, let's just make a table. Okay. Now remember, I can't square root a negative number, so the smallest number I can put in here is 3, and I'm going to get out 0, because 3 minus 3 is 0, and I square root that, I'm going to get 0. So at 3, I'm going to get 0. That's 1, 2, 3. It's really hard to see this graph on the projector here, but I'm going to get out that number right there. Okay, I can't put in 2 because 2 minus 3 would be negative 1. I can't square root negative 1. So I'm going to go the other way. I'm going to plug in 4. 4 minus 3 is 1. Square root of 1 is 1. So that is a friendly point right there. It's going to go right there. Okay, now I'd like to have a really friendly number come out of this thing. I'd like to have a whole number come out. Well, the next perfect square is going to be 4. So I'm going to need a number that will make this 4. So if I put in 7, 7 minus 3 is 4. When I square root that, I get 2. Okay, so 1, 2, 3, 4, 5, 6, 7 is going to give me 2. So my graph's going to look like this. Notice I put an arrow on the end because that thing's going to get bigger forever. Okay, now how is that different than the square root of x? Well, it looks just like the square root of x, except that it's shifted over 1, 2, 3 to the right. And remember, when I subtract a number inside a function like I did this minus 3 from the x, that's a shift to the right, whatever that amount is. If this was a plus, it would move it this way, move it left. And then again, if I use transformations, if I add a number outside the square root, that moves it up, and if I subtract a number outside, it moves it down. Okay. Now, what if I do this equation? G of x is the negative square root of x minus 3. Well, it's just going to take all the answers. I mean, this part is the same as this part. It's going to take all the answers here and make them negative. So if I made that table, whoops, if I plug in 3, I'm going to get 0 because negative 0 is 0. If I plug in 4, I'm going to get negative 1, and if I plug in 7, I'm going to get negative 2. So let's graph those. I get 0, 3, 0, I get 4, negative 1, and I get 7, negative 2, and so it makes a mirror image of that thing. So when I throw a negative on the front of this thing, all it does is flip it over the x-axis. Okay? Now if I had moved this, this way and then this way, so it was up here, it wouldn't flip it over the x-axis, it would just flip it over whatever line, horizontal line goes through the endpoint here. So if I do both the plus and the minus of the same equation, I'm going to get a kind of a parabola on the side. Okay, sketch the graph of the cube root of x plus 2 plus 1. Okay, so I could graph the cube root of x, which is very simple to do. I mean, we know that the cube root of 0 is 0. We know the cube root of 1 is 1. We know the cube root of 8 is 2, so 1, 2, 3, 4, 5, 6, 7, 8, 2 right here. We know the cube root of negative 1 is negative 1. We know the cube root of negative 8 is negative 2. So, my cube root's going to look like this. Okay, that's my cube root of x. Okay. Oops, let's not call it f of x. Let's call it g of x. I always like to do these by transformations because it's so much easier. So there's my cube root of x. Now, if I want this tells me move it 2 to the left and 1 up. Okay, so I just pick a point on here like this, 0, 0 right here. I'm going to move it 2 to the left and 1 up. It's going to look just like that. Okay, then I can get rid of these other points that are on here. And I've got my graph. I should have a arrow on the end there. Okay. Oh, and you know what? I should have made that a different color. Uh-oh, what did that do? That's weird. Move it back. Okay, so there's that one. Okay. The shoulder height h in feet of a male African elephant can be modeled by the equation h equals the square root of 13t plus 3 when t is greater than 0, where t is the age of the elephant in years. Sketch the graph of this equation. Okay, so I would just, on this, I would go ahead and make a table. The youngest elephant would start with 0, would come out to be 0, right? Oh no, it'd be 3, I guess, wouldn't it? Now that doesn't make any sense. Oops. Because you can't have, I guess it would, if it's born, it's basically age 0. So it'd be 3 feet. So I'd go ahead and 1, 2, 3 would be right here. Okay, at 1 year of age, that would be the square root of 13 plus 3. I'm going to go ahead and grab a calculator so I can get a number that's nice to work with here. So the square root of 13, 3.6 plus 3, so that's going to be 6.6 feet. Okay, so this thing's growing pretty quick. It doubled its size. 4, 5, 6, going to be right there. No, it's going to be a little higher than that, actually. It's going to be almost 7 feet at the shoulder at that point. Come on. Okay, Let's try it again. 1, 2, 3, 4, 5, 6, almost 7. There we go, that's better. Okay, if I plug in 2, the square root of 13 times 2 plus 3 is going to give me 10.21 feet. Okay, so at age 2, 10.1, 10.2, that's going to be like right here. This thing goes off the charts here real quick. All right, what if I go out to 20? Age 20. That would be 20 times 13. That would be the square root of 260 plus 3. 19.1. So it's growing slower and slower. I go out here 20. I'm going to have a graph way up here. So this thing, I didn't choose my graph very well. It's going to kind of look like this because it's the square root. Okay, so it's got the square root curve. It's just kind of stretched a little bit this way. And you can see it's growing slower and slower, which makes sense. Okay, you're not going to grow as an adult like you do as a child. Okay, so here we got some assignment for you, some things to graph. Have fun with that, and I'll talk with you guys later.